proofs. There will be some that are not proofs, but the majority will be proofs. And we're going to practice and practice until we get great. I will warn you though, again, when students tell me they're struggling with proofs, it is not because they don't know how to write a 2-column chart. It's not because they don't know that statements go on the left and reasons go on the right. It's not because they don't know to number their statements and their reasons. It's because they don't know the theorems and the postulates or the definitions. Most of them know the properties. Those property charts, pretty easy: addition, subtraction, multiplication, division, reflexive, symmetric. Most people know that, but they don't really know their postulates and theorems. And so if you're struggling, I would remind you again to open that textbook to the back in that little sea green section. Look at chapter 1's postulates and theorems, look at chapter 2, look at chapter 3, and then look at chapter 4. There may be a few things in chapter 4 we haven't learned yet, so towards the bottom of that may not be things we've gotten to yet. But it may be a place that you could scan and go, oh yeah, I forgot about that. That's the name of it. Or I forgot what it said. That's my advice. You need to study those to get really good at proofs. Okay, so we're trying to prove that our shapes are congruent today. To prove they're congruent, geometric figures are considered congruent if they are the same size and the same shape. But more specifically, all of their corresponding angles and all of their corresponding sides, bless you, must be equal or congruent. Okay, so for 2 polygons to be congruent, their corresponding sides, and I want you to add right here, and their corresponding angles in order for 2 polygons to be congruent, their corresponding sides and their corresponding angles must be congruent. And by corresponding, we're not talking about 2 lines cut by a transversal here. We're talking about corresponding, meaning the sides and angles that are in the same position in those polygons. Okay? So when we're saying corresponding angles and corresponding sides, we mean that in the 2 polygons, those angles are in the same position. When you land them on top of each other, the angles that would be in the same spot, the sides that would be in the same spot. Okay? So what we're going to have to do in order to prove our 2 shapes are congruent is we're going to have to get every corresponding angle congruent and every corresponding side congruent. If that's a triangle, how many sides are in a triangle? 3. How many angles? 3. So that means we're going to have 6 pieces of information listed in our proof before we can say the 2 triangles are congruent. If it's a rectangle, how many angles are there? How many sides? So that means you would have to have 8 things congruent before you could say they were congruent. So if we were going to prove a decagon was congruent to a decagon, okay, how many sides are in a decagon? 10. And how many angles? 10. So you would have to have 20 things congruent, right? So we are not going to be proving decagons congruent. The whole focus of chapter 4 is going to be proving triangles congruent. In this section, you may have one that's a rectangle or a quadrilateral that would require those 8 parts marked congruent or listed congruent. But we won't go any bigger than a 4-sided quadrilateral, okay? But just know, we're not learning this long way to torture you. We're learning it because it's the only way if there's more than 3 sides, okay? If there's just 3 sides and it's just a triangle, then tomorrow and next Monday, we're going to get to learn shortcuts on how to do that and not have to have near as many steps, okay? So there is a reason. I'm not just trying to be mean to you. Okay, part of your homework that is not proofs. They're going to simply ask you to name the corresponding angles. So you're going to look at the picture and you're going to say, okay, which angles are marked congruent? A is marked congruent to D, B is congruent to, and C is congruent to. And you will just list it with correct chapter 1 notation. Angle A is congruent to angle D. So this is not for proofs right this second. I said part of your homework that is not proofs will be something that simply just says name your corresponding angles. And so if it says name the corresponding angles and they give you a picture, you're just naming with correct notation which ones are congruent. Does that make sense? Same for the sides. If it says name the corresponding sides, you're going to match up the corresponding sides. But I'm going to be kind of picky about this. It doesn't matter how you name a line segment, whether you name it AB or BA, right? But it is going to matter when we're doing our proofs. So when you do it, I want you to make sure not only when you're naming your sides, do your sides match up, but do the angles in the names of those sides match up. So in other words, I don't want to say BA is congruent to DE because angle B is not congruent to angle D. Does that make sense? So what I want you to be careful with is to make sure that when you're naming your sides congruent, that you're also making sure that the letters that stand for the angles are matched up as well. So if I say AB, the way I think about it is I'm going from one angle mark to two angle marks. So over here I'm going to go from one angle mark to two angle marks. So DE. Does that help? Making sense? So part of your homework is just simply going to say, name the corresponding angles, name the corresponding sides. I will not accept things like angle A and angle D. Use the congruent symbol. You're saying they are congruent. Okay? So make sure you're writing it just like this chart looks. Any questions? Okay, the other thing that's going to be huge for the rest of this school year is what this statement right here is and this statement down here is. And you don't need these words polygon. So if you want to cross those out, you can. They don't tell you this right here, but this is called a congruence statement. Both of these are called congruent statements. Congruent statements you are going to have to write a lot. Congruent statements are where you are naming the two shapes that are congruent. When you name them, the order in which you put the letters matters. You are saying angle A is congruent to angle D. Angle B is congruent to angle E. You're also saying side AB is congruent to side DE. So the way you name your congruent statement tells you all the information in your picture. If you don't name it correctly, then it's going to be wrong. Sometimes they will draw pictures that don't match up the way you think they should match up by just looking at them. You are always going to use your congruent statement. Your congruent statement is the truth. Whatever it says is the way it matches up. If it says A is congruent to D, it doesn't matter if it doesn't look like A is congruent to D. A is congruent to D. Okay? So always go off your congruent statement. So part of your homework may simply say write the congruent statement. It may say name the corresponding sides, name the corresponding angles. Even if they're not marked congruent, but they tell you they're congruent, and they say name the angles and sides, you're going to name the ones that match up. Okay? All right. So I think I've already mentioned this a couple of times this year, but just a reminder, when you are naming a polygon, for example, if you had a rectangle, PQRS, you cannot name that PQSR because that creates a Z, right? So always make sure that when you're naming them, you are either going clockwise consecutively or counterclockwise consecutively, but never in a zigzag pattern. And I already said this, when you write your congruent statement, it is telling you which parts are congruent. So you base all your decisions off of that statement. It is the truth, no matter what the picture looks like. Okay, so here's the first kind of example that is not a proof. It simply says, identify all pairs of corresponding congruent parts. And they give you a congruence statement. So you are just simply going to list the angles and the sides that are congruent. Some of you may need to draw a picture. Some of you won't need to draw a picture. You can just look at the statement and list them all. Let's start with the angles. Can somebody give me one pair of angles that are congruent? Okay, so angle P is congruent to angle S. Somebody else? Angle R is congruent to angle W. And what's the one we're missing? Angle Q is congruent to angle T. Anybody lost on how I knew those? Okay, sides. Again, if you need to draw a picture and label two different triangles, you can, or you can just use the statement. Tyler? Very good. So segment PQ is congruent to segment ST. And again, you can just look at the order that they're listed in the congruent statement. What's another side? QR is congruent to TW. And the last one? Very good. PR and SW. But again, if you don't see it in the statement, then draw yourself a picture. Draw two triangles. Just make sure you label them in the same order. P, Q, R, S, T, W, and then you can match up your sides. Questions? Okay, so some of it's super easy like that. No proofs there. Then you have some problems like this, where does it actually say find the value of something? Oops, sorry. Yes, so find the value of x. So this is also not a proof. It does say given, but it doesn't say prove anything, right? It just says find the value of x. It doesn't say write a justification for each step. It doesn't say anything like that. So all you're doing here is using this congruent statement to decide what parts of the triangle are congruent, and then using that information to solve for x. This is where I would warn you. Some of times they'll be tricky and they'll draw a picture where you feel confident by looking at it that, oh, this side matches up with this side. And then the statement says something entirely different. You go off the statement, okay? Not what you think about the picture. So they want us to find x. What angle is x pointing to here? Okay, angle C, or using three letters, that would be angle ACB, right? Because there's two angle C's. So that means angle ACB should match up with which angle? DCB. Same order, right? So DCB is what angle measure? 90. So if they're congruent, what does that mean about their measurements? They're equal. So then you just have a problem of 2x minus 16 equals 90. Again, not a proof. So you'll have questions like this that are not difficult. You're just using your statement to make sure you're matching them up correctly. So add 16, 2x equals 106, divide by 2, and what is x? 53. Does it say to plug it? Did I add it right? Yeah. Okay. So once you find your x, do you have to plug it back in for anything? Nope, it just said find x. There's no proof, no justifications, you're done. Pretty easy? Okay, but again, I'm going to say it for at least the third time today. Don't assume anything about your picture. You only can assume what the congruent statement tells you, okay? Oh, then this one goes on, it's the same thing, but now it wants us to find the measure of angle DBC. So find angle DBC. Suggestions on how we might figure out what that angle measure is. Ridley? Which other angle?
Sorry, 49.3 is congruent to D down at the bottom.
Okay, so 49.3 is angle A, and angle A is congruent to angle D. So this angle is 49.3, okay? Okay, very good. And we could do that. I'm going to remind you of a shortcut that we learned, but you can definitely take 90 plus 49.3 and subtract it from 180. Or remember the corollary we learned. If we have a right triangle, what do the other two acute angles have to be? 90. So a shortcut is just to do 90 minus 49.3, which may make the math just a little quicker or easier without having bigger numbers. And while we don't have a calculator, I'm always looking for ways to have smaller numbers to work with. Does that make sense? Both will give you the same answer, so it really doesn't matter. So I'm going to borrow from my 9 and then borrow from my 10. So this is going to be what? 40.7. And what's my units? Degrees. And then if you're writing the actual answer again, I would remind you not to forget to put your little M for measure. Any questions on that one? Okay. Okay, same thing here. Same kind of a problem. They're asking you to solve for x. So what would we do? And we know it's the segment because what is not with it? There's no degree symbol, so it's not talking about an angle. It's talking about a side length. Very good. I'm hearing all three of you saying the same thing there. AB is where the x is located, 2x minus 2, and that is congruent to DE, and DE in the picture is 6. Okay? So then we can just say 2x minus 2 equals 6. Add 2. 2x equals 8. Divide by 2, and x is 4. And it just said find x, so we're done. Okay, so again, if you can prove that two shapes are congruent, then you can use that information to find missing parts. So that would be the purpose in us trying to figure out, are these shapes the same, so that then we can figure out what missing measurements are. But before we can do that, we're going to have to figure out how to prove that they're congruent, unless they tell us, like these examples, that they were congruent. Okay, and the next one just says find f. Let's see if we can do that real quick, and then we're going to move on to proofs. So we're looking for angle F. Suggestions on how we could do that? Okay, so B is congruent to E. Good. So if B is 53, then E is 53. And then again, we could add those and subtract them from 180 or use the shortcut since this is 90. The other two are complementary. So 90 minus 53 is what, Alexis? 37. Okay. Sorry, I thought you said 47. So 37 degrees. And again, little m for your measure. Any questions on the problems that are not proofs? Okay. So now we're going to get to some proofs. Remember, we talked way back that the very first thing 95% of the time in your proof is going to be what? Given. Okay? Here is where we start, and marking your picture is going to be huge. So every single time you write a proof, I expect you to draw the picture on your paper. You are going to have some given and what you're supposed to prove. What you're supposed to prove should go where in your proof? The very last statement. There should be no question about what your last statement is. Your given today, I'm going to tell you that my best advice and what I have found that works the best for students is to break it up. Don't write all your given at once, because then you write all this information and you don't know where to go from there. Write one part of your given and ask yourself, do I know anything from that? Then go back and write the next part of your given. Do I know anything from that? Our ultimate goal today is going to be to prove that two triangles are congruent. To prove they're congruent, we're going to have to get 3 sides marked and listed in our proof congruent. And we're going to have to get 3 angles marked and listed in our proof congruent. And as soon as you have all 6 pieces marked and listed congruent, then you can say the triangles are congruent. The one thing I didn't point out, and I should go back and do that, but I'm not going to flip back in the notes. You can if you want to. The only reason that you will have learned today for why your triangles are congruent, and there's only one option today, we haven't learned any other way, is by the definition of congruent. And you can either say polygons, or you can be specific and say triangles, since we're dealing with triangles. But you could say polygons if it was any other shape.
Senior's last name beginning T through Z. Please go to the cross connect sign. Graduate cell. Senior's last name is T through Z. Please go to the cross connect. Thank you.
Okay, so definition of congruent triangles if it's triangles, or you can say polygons if you want. If it's a quadrilateral, you won't say triangles because it's not a triangle. This is your only option. So there will be no guessing when you get to the end. What's my reason why they're congruent? Definition of congruent triangles. Once you have all 6 parts marked congruent, then the triangles are congruent. Now, I will want to preface this as well. Once we start learning our shortcuts, if you have a question on the test about proving triangles congruent, you do not need to go and use definition of congruent triangles. That's way more work than needed. Use the shortcuts that we've learned, okay? So if it's any other shape, this is your only option. Okay, so let's make a T-chart, and I think for your notes, I provided you with a statement reason chart, didn't I? Okay, and I should for all of this chapter where we're doing so many proofs. So I'm going to create one for myself up here. And then we're going to list our given one at a time. So number 1, we are given that angle YWX and angle YWZ are right angles. Remember that you can use symbols, but you are not allowed to abbreviate anything else. And the reason is given. Then I'm going to remind you, go mark your picture. When we get to the shortcuts tomorrow, if you don't mark your picture, you will not know what your answers are. You have to mark your picture. So they already marked YWZ was a right angle, but they didn't mark YWX. So let's mark it. Okay, what do we know about right angles? Okay, we could say that they are 90 degrees. That's going to require several more steps in our proof to get that they're congruent. But right angles aren't complementary. Complementary means 2 angles that add to be 90, and a right angle is already 90 all by itself. Okay, that would be true, but let's think about what our goal is. Our goal is to prove that we have all 3 angles correspondingly congruent and all 3 sides correspondingly congruent. So what we're trying to prove is not that they're supplementary or complementary or any of those things. We're trying to prove that these 2 angles are what? Congruent. We want them to be congruent to each other because we're trying to prove that these 2 triangles are congruent. And why are they congruent? Okay, my answers for reasons are not statements where I write them out unless there was no name for it. My answer needs to be a theorem, a definition, or a postulate.
So you can say something like right angles.
Okay, so I'm going to write what you're saying to show you that we can definitely do that, but it's several steps. So the measure of angle YWX is equal to 90. Oops. And the measure of angle YWZ is equal to 90. We could do that. Why do we know they're equal to 90? Okay, I want you guys to try really hard today to not start explaining things to me when I ask you why. I want you to try really hard to only answer with a definition, a theorem, a postulate, or a property, because that's what's going to have to go here, not an explanation. Okay? So definition of right angle. Okay, where would we go from here, Bree? If they both equal 90, what do we know? Okay, so this was one statement. The next statement would be the measure of angle YWX equals the measure of angle YWZ. And why? It's not definition of congruence. That says if something is congruent, then it is equal, or if it is equal, then it is congruent. We didn't change from congruence to equality. Transitive property, be careful. So often confused with substitution, but if the entire side of the equation is the same as the entire side of the equation, that is transitive. So we could use transitive property. Now what do we need to use to say they're congruent? So now we're saying if they're equal, then angle YWX is congruent to angle YWZ. And we could do that. It would take 3 steps. And you can do that every single time. Or we learned a theorem that said all right angles are congruent. What theorem name was all right angles are congruent? So here's a suggestion. Everybody should grab their textbook, open it up to the back where I told you, so you can scan through your postulates and theorems. It's not right angles theorem. Right angle congruence theorem. You were close. So, understand what Bree said would be totally fine. You could take 3 steps and do that, and you would get full credit in your proof. Totally fine. If you forget the theorem. Or, as soon as you know that 2 angles are right angles, you can go straight to angle YWX is congruent to angle YWZ. And the reason Tyler said was right angle congruence theorem. You're not done. You're done with that angle. How many different congruent statements do we have to get before we can prove the triangles are congruent? 6. 3 angles and 3 sides. How many congruent statements do we have right now in our proof? 1. We have 1 pair of angles. When we say 6, we're talking 6 pairs of information, right? And right now we only have 1 pair of angles congruent. So we have to get how many more? 5. Okay, so we're not done until we get 5 more and we write what we're trying to prove. Okay, but it's not hard. It's just going to take a little bit. So we've already got 1 angle, and that came from our given. So where are we going next, Tyler? To the next given. So go back up to your given and write the next thing. The next thing they tell us is that segment YW bisects angle XYZ. And again, that's given. So now you need to go to your picture and you need to think about what you just wrote down. Segment YW bisects angle XYZ. What does that mean? It's not bisecting a triangle, it's bisecting what? Not the line at the bottom. It didn't say that the segment was bisected. What's being bisected? The angle. What's doing the bisecting? The segment. YW, this line segment, is bisecting this angle. X, Y, Z. So what does it mean to bisect? Okay, don't use cut in half. That's true, but that's not really our definition. What does it mean to bisect? To split into 2 congruent parts. That's going to be huge because when you see that word bisect, you've got to think, what do I now know next? I know if it bisects that it splits it into 2 congruent parts. What are the 2 congruent parts? Careful, not YXW. XYW. So this angle is congruent to? Okay, be careful. ZYW. When you name it, remember you're going to try to name it so that the angles are matching up as well. So do we agree that if we were to fold that triangle in half, that this Z is going to land on X, W is going to land on itself? Is everybody following that? Okay, so this is often confused with the YW being bisected. YW is not being bisected, it's doing the bisecting. So what is the next thing we can say here from statement number 3 to number 4? Angle ZYW, go ahead. Good. Angle ZYW is congruent to angle XYW. And what's the reason that they're congruent? Definition of angle bisector. Very good. Don't make that harder than it is. They told you the word right up above. I don't know how many times students try to come up with something crazy, and I'm like, how did you know it? The word right above is how you knew it. Use that word, okay? I would not count off if you put definition of bisects, but definition of angle bisector is actually the correct, most appropriate, perfect answer, I guess. But definition of bisects would be acceptable for me as well. Okay, we marked our picture. We now have 2 things marked congruent and 2 things congruent in our proof. How many do we need? 6. So we need 4 more. So I'm going to come over here because I'm running out of room. Do not ever put S and R. This is bad modeling, but I'm going to shorten my steps. So 5. Okay, what are we going to write next? Or yeah, this is 5. The next given, and the next given says W is the midpoint of line segment XZ. Given. Now, I may not have given you enough spaces, I don't know, in your statement and reason box. Just heads up, I may give you too many and I may not give you enough. So just because you see 10 there doesn't mean we necessarily have 10 steps, okay? All right, so if W is the midpoint of XZ, what do we know?
Segment XW and segment
Perfect, Bree, good job. And set it the way we need to write it as well. XW is congruent to ZW. Definitely putting line segments because we're using those congruent symbols. Yes, and what word did we use to get there? The word midpoint, so it is just simply the definition of midpoint. Because the word's there. Yes. The word's there. If you're using definition, it means the word was listed somewhere in the proof. So think about that. Like, it shouldn't be the definition of some crazy word that you never saw before. It should be somewhere in your proof. Okay? Okay, so we have that. We've marked it. So now we have 2 angles and 2 sides. So where do we want to go next? Or 2 angles and 1 side, sorry. Where do we want to go next? We have another given. So number 7. XY is congruent to YZ. And that is given. So XY and YZ, mark your picture. XY, 2 marks. YZ, 2 marks. Don't use the same number of marks. So now how many pieces do we have marked congruent? 4. How many do we need? So the next 2 are not going to come from our given. They're going to come from something that we've learned before in this class. So what's missing that's not marked? YW. YW is our third side. And what is it congruent to? Exactly, because in those 2 triangles, they share that same side, right? So it's the same side in both triangles. So what Bree said is exactly what we would write. YW is congruent to YW. You can't split it apart because they share that common point, and you would have to call it a different point, and it's not a different point. Okay, but what did we learn tells us that something's congruent to itself. Reflexive property. And if you remember when we learned it, I told you we would use it a lot when we got to geometry, and this is where you'll use it all the time. So this is reflexive. Good. Property. And remember, it's flex like you're flexing your muscle, not flect like reflection. Reflexive property of congruence, because we're using a congruent symbol. Okay, that's 5. What else are we missing? The angle X and the angle Z. So what did we learn yesterday? Say it again. Good, Alexis. The third angle theorem. If 2 angles in one triangle are congruent to 2 angles in another triangle, which we have 2 marked congruent to 2, the third angles are congruent. So 9. And since there's only 1 angle there, you can just name it with X and Z. You don't have to use 3 letters. You can, but you don't have to. So angle X is congruent to angle Z. And I'm running out of room down here. This is going to say third angles theorem. Third angles theorem. Are we finished? No, but we only have 1 more step left, right? Because now we have all 6 things, so we're going to list what we're trying to prove. So number 10 should be identical to what's listed by prove. It should never look any different. So it should just be triangle XYW is congruent to triangle ZYW. Exactly, and the only choice you have today to prove triangles congruent, so there's no wondering or guessing. And I ran out of room here, so I'm going to come up here for my reason. Number 10 is definition of congruent triangles. So it's long, but is it making sense? Okay. So I think what you're going to find is that the proofs in Chapter 4 turn out to be easier than the proofs we've done so far because there's going to be a pattern more like an algebraic method. You've got to get these things marked congruent and listed congruent. You know exactly what you have to do to get there. It's just, yes. And again, this is the long way. When we get to tomorrow, we're going to shorten this way down. It's not going to be near as long. Okay. Yes. So today could be longer. Because it gives you everything and it does it in its order and not necessarily what you guys would think. So I just figure I'll write it along with you. Plus, I tend to talk too fast, and so that slows me down if I'm writing it too. So I've learned over the years I need to slow down. Okay, so we're going to try another one. Here we go. And we're going to do several together. We're just going to keep working until we get really good at it. Okay? I have no idea. It's not super long. It's nothing like yesterday. Okay, so here we go. Statements and reasons. You've already got your box. We're going to start with our first statement. And again, did you think it was helpful to do one given at a time? Okay, so I really think you'll find that easier as we go along as well. So the first one says segment AD bisects segment BE. And the first reason is given. Okay, so AD is doing the bisecting, and what is it bisecting? BE. So what does that tell us? Karina? Okay, good, but be careful. So BC is going to be congruent to this piece, but when we name it, is C going to land on E when we connect these triangles? So BC is congruent to EC. Okay, so again, that's just Lashley being picky, but I want us to try to constantly keep things matched up that are congruent, okay? And I think it'll just help us in the long run. Oh, yes, I'm sorry. There's already one here, but we don't have it in our proof yet. But yes, so that should be 2 tick marks. Thank you. BC is congruent to EC. And the reason? Definition of. True answer would be segment bisector, because you're bisecting a segment. But again, I wouldn't count off if you put definition of bisects. Definition of segment bisector. But when we get to that end of course test and somebody else in a different place in the state's grading your paper, the more precise you can be, the better, okay? All right, so go to our next given. And even though we've got more than one thing marked, we really don't know those yet in our proof. So I always go to my proof and say how many things are in my proof, okay? So right now we only have one thing listed in our proof. Next given is that BE bisects AD. So now they just flipped it around. BE is doing the bisecting, and what's being bisected? AD. So what can we say? Good. AC is congruent to DC. And I forgot to list my reason given over here, so I'm going to list it real quick. Number 3 was given. Yeah, AC/DC. So number 4 would be AC is congruent to DC. So again, a segment is being bisected, so definition of segment bisector. They told us the word bisect, so we know it's the definition of bisect, and the picture is of a segment. So definition of segment bisector. Okay, so now we have 2 things listed in our proof. Go back to our given. The next 2 things in the given are just pieces that are congruent, right? So you could, if you want to, write them both in the same thing if it's helpful, or you can write them separately. So AB is congruent to DE, given. Make sure it's marked, which they already marked it for us. I'm going to go ahead and put it in blue just so we've listed it. And then I'm going to come up here because I'm running out of room down there. Again, don't do S and R. Number 6 would be angle A is congruent to angle D, given. And make sure it's marked in your picture, which it is. And again, you could have listed both of those at the same time since there's not really a statement we're trying to come up with what's congruent next. Does that make sense? Okay. So now how many things do we have listed in our proof and marked in our picture? Okay, 4. 3 sides, so all of our sides are marked congruent, right? And then we have 1 pair of angles. So we need to get 2 more angle pairs, and that's all the given that we have. So now we got to think. Look at the picture. What is something we learned previously that we know would be a reason why something's congruent? Which angles do we need? Go ahead, Bree.
Okay, so Molly brought up the whole. Okay, fine. So like vertical angles theorem.
Perfect, yes. Vertical angles theorem. What does vertical angles theorem say? Vertical angles are congruent. And do we have some vertical angles in this picture? Yes, which angles? Okay, I heard BCA first, but you could have said ACB either way. BCA, now be really careful when you name the other one. We went from the 2 marks down to the 3 marks. So it should be what? ECD. So again, I always look at my markings. 2 marks here. So we said BCA. So then I'm going to start over on the side with 2 marks. ECD. Because what's happening to this triangle on the right is we're technically flipping it over before we flip it across, right? To get it to land on top. Okay, so number 7, we could say angle, I heard BCA, right? Is congruent to angle, and then again ECD. And the reason was again, vertical, angles, yeah, said it and still spelled it wrong. Vertical angles theorem. Okay, so that is, I didn't mark it, hold on, 2 angle marks, 2 angle marks. And then the third angles theorem, and I told you guys we're going to use that a lot. Third angles theorem. So we can just use one letter. Angle B is congruent to angle E because there's only one angle there, right? C, we had to use 3 letters because there's more than one angle. And that's third angles theorem. It's not bad, right?
You say it's not bad right now, but then when you get home,
I'm telling you. But we're going to do a lot so we get good. Okay, but we're not done because we didn't list our final statement. But we do have all 6 things listed and marked now. Right? So now, triangle ABC is congruent to triangle DEC. And the only reason you have today for number 9, definition, do not abbreviate, but I'm running out of room. Definition of congruent triangles. So there shouldn't be any guessing today. If the statement says prove these triangles congruent, there's no guessing. That's the only option. Okay? Tomorrow we're going to learn 5 shortcuts. And so then tomorrow you're going to have to figure out which of the 5 are you using. You say that until you can't because there's not enough information. You're going to need the shortcut. Okay? All right, let's try another one. I'm going to do this one on the board because there's not enough room up here. Okay? So if you're watching the video, Sarah, we miss you today, by the way. So if you're watching this video, let you know we miss you. I'll try to state this, but keep in mind if you're watching the video that the filled in version is in the notes. So if you don't follow what I'm saying, then look at the filled in version and it'll be all typed up neatly for you for this example. Okay, so number 1, our goal again, I should say this, I haven't really said this to prepare you for future proofs, but look at what you're trying to prove first because it's going to change eventually. One day we're not going to be proving triangles congruent. So we're trying to prove triangles congruent again, right? That's our goal. And we know the only way to do that today is to get all 6 pieces marked congruent. So start with our given. Segment PR and segment QT bisect each other. Given. So this time they didn't break it up and say our PR bisects QT and then say QT bisects PR. They just all at once said, hey, they're bisecting each other.
Does that mean that we can list the
We sure can. So let's start listing the things that we know are going to be congruent. If PR is bisecting QT, what could we mark congruent? QS and TS. Okay? But if QT is bisecting PR, what can we mark congruent? Good. So PS and RS. And I used 1 mark and 2 marks. And then, as Bree said, can we state them all at the same time? Sure. Because we're going to use the same reason for all of that, right? Okay. So you said QS is congruent to TS. And then you also said PS is congruent to RS. And the reason for that is? Good. Definition of segment bisector. Again, that's because what we're bisecting are segments. Mm-hmm.
Okay, this is sort of a weird question. What if they bisect each other?
It depends. Just because they bisect each other doesn't mean that they are all 4 pieces congruent. It would depend on the lengths of them. So we don't have enough information to say that. Okay, I should point out, by the way, how many triangles are in this picture? It's actually more than 4. There's definitely 4 little ones, and then we've got these big ones here, right? And big ones here. So we probably should stop for a second and make sure we know which 2 triangles we're actually trying to prove congruent. Okay, so we want QPS, which is this one, and we want TRS, which is this one. So we're trying to get the left and right triangles congruent to each other. Okay, that's important, because if we were trying to do the top and bottom, we might not get the right angles and stuff, okay? All right, so let's go back to our given. Number 3, we have angle PQS is congruent to angle RTS, given, and we can mark it. PQS, be careful you're marking the correct angle. PQS, oops, use blue. PQS is congruent to angle RTS. And then we can go to the next given. Is that okay? So then we have QP is congruent to RT. And that's given. So QP we'll mark with 3 marks and RT with 3 marks. So now, where can we go? So I heard Alexa say vertical angle theorem, and say what you said again. Very, very close. QSP is correct. But again, Lashley's picking us about making sure everything matches up. Okay, angle QSP. So QS only had 1 mark. So we went 1 mark to 2 marks. So I'm going to do the same thing down here and do TSR. Does that make sense? Good, Elena. So then this angle, it's congruent to this angle. And it was angle QSP is congruent to angle TSR. And Alexa said that was the vertical angle theorem, yeah. So vertical angle theorem. So what are we missing? Good, third angles theorem. We've got 1, 2, 3, 4, 5, and the only thing we don't have is the third angle. So angle 6, or number 6, what's our angle name? Angle QPS is congruent to angle. Good. So we went QPS, so we went from 3 marks to 2 marks. So since we're trying to talk about this angle, we have to go from T3 to 2, so TRS. Is that making sense to everybody? Okay. And then the reason was third angles theorem. And now we have all 6, so we can go straight to what we're trying to prove. Triangle QPS is congruent to triangle TRS. And very good. Definition of congruent triangles. And here's a little trick for you. Bless you. If you're ever unsure if you've named it correctly, but they have given you a congruent statement, look at your congruent statement. If you weren't sure what QPS, if it was supposed to be TRS or SRT, look at the congruent statement. QPS should match up with TRS. So that will tell you by looking at the congruent statement if you're ever unsure about how it should go. Does that make sense? All right, good. Okay, how many's left in our notes? One more, let's try it. And I know it's a lot. Okay, I like that idea. Yes. So I'm going to, on this one, since you guys started it without me, I'm going to go ahead and just use this chart and kind of show what they were doing. So you started with your given. Do you have this? Okay, this may be somewhere else in your given. Is right? Is it like one of the other steps on down? So what number did you make this? Okay, 3 or 5. So this is later, 3 or 5 on some of yours. Okay, but you have it. Everybody has that marked and in their picture. Okay, and then do you have JK's parallel to ML? Okay, that's 7 for you guys. Okay, and then, oops, I'm going to come back to that. Okay, so I'm not going to do that because that's not going to help us. Because that's just going to tell you what to do, and that's not what I want to do. Okay, so I'm going to redraw this. And let's talk through what you should have in your paper. So this is J, K, N, L, M. Okay, so from the first given, MK bisects JL. From that only, what did you mark? Okay, so JN should be congruent to LN. So if you wrote the first given down, then the second thing you should say is JN is congruent to LN. I want to be very clear. You can't say the other one because you haven't listed that in your given yet. Okay? So if you put both of them at the beginning, so you had to put this and this as your first given, then you could list both of them as your second statement. Okay? Okay? And what's the reason? Okay, I'm going to abbreviate, but don't abbreviate. Definition of segment, dissector. Okay? Just trying to go faster here. Okay, so then Bree said that she wrote her given up there, number 1. Some of you guys wrote the next given here. So statement number 4 would be, since JL is bisecting MK, okay, MN and KN are congruent. So MN is congruent to KN. Same reason, right? So I'm just going to do ditto mark, same reason. Okay, anybody not got that correct? Okay, so then we go on and now we have the JK is congruent to ML. So we can just mark our picture and list it in our proof. That's more of the given. And then JK is parallel to ML. Those are those little arrows that we put on our pictures, right? So number 6 is JK is parallel to ML, and that was all given. Because as far as these givens, this given is telling me exactly what's congruent, so there's nothing I conclude from that. It is giving me the congruent statement. Whereas this one just told me something was bisected, it didn't tell me something was congruent, and I was able to conclude that from the word bisects. Okay? Okay, are we good there? Okay, so if they give you a congruent statement, a piece that's congruent, you just write it down and mark it and move on. Okay? So now we only have 3 sides marked congruent. We don't have any angles marked congruent, but we do know JK is parallel to ML. So before we go anywhere different, I want to start with just that. What do I now know if this line, and be careful, we only have one pair of parallel lines, if this line is parallel to this line from last chapter? When you have parallel lines cut by a transversal, so pick a transversal, give me one line that's JL is a transversal. Okay, I said just give me one though. We don't want to look at both at the same time or we'll get confused. So let's look at one transversal and 2 parallel lines. What could we say based off last chapter? Alternate interior angles. Name them for me. Which ones are alternate interior with the purple lines? Say it again, Morgan. Hmm.
and
Very good. Did everybody hear Morgan? KJN and MLN would be alternate interior angles. If the lines are parallel, your next statement should be angle KJN is congruent to angle MLN. Doing a great job to name those appropriately. And what's going to be the reason for number 7? Alternate interior angles theorem. No converse? Nope, because we're not stating lines parallel. And everything builds, right? So things we learned last chapter, we're using again now in our proofs. Alternate interior angles theorem. Are those the only alternate interior angles we could mark? No, because now we could go back and look at the other transversal we see there, right? So we could look at this one. Yes, and use these parallel lines. So now if you look at what I have in blue, LMN I heard, sorry, and JKN. And what's the reason for that? Alternate interior angle theorem. So can we put it on 7 at the same time? Okay, I would just to save room. So this is angle, again, LMN congruent to angle JKN. Bree, did I go too fast there?
no, I just messed up.
Okay. You have to have all parts marked congruent. So in order to prove these two triangles congruent, which are the two we're trying to prove, then we've got to get all the angles and all the sides. 6 things marked congruent. So we're still missing our third angle, right? And what's the reason? Always third angle theorem. There is not a third sides theorem. Do not ever use third sides theorem. It doesn't exist. Just because 2 sides of a triangle are congruent does not automatically mean the third sides will be congruent, right? That's isosceles versus equilateral. So there's nothing that says that. Okay, so number 8, how do we want to name those angles? Angle JNK is congruent to angle. Very good, Edwin. J only had 1 mark, so make sure you start with the one that had 1 mark. LNM. What's the reason? Third angles theorem. And that should be all 6 pieces, right? Good. So Ridley said, well, what could we not have said that this was vertical angle theorem? And yes, you could have, because they are vertical angles. So you could have either reason, and you could have done only one alternate interior angle, then use vertical angles, and then use the third angle theorem for the other pair, and it would still be correct. So it's like a lot of practice of doing proofs. I remember struggling in high school. Geometry proofs were the hardest thing I learned in math in high school for me. And then I went to college and learned that proofs can get so much harder than what I ever imagined they could get. And I sat in my professor's office hours many, many times. And I wrote down stuff on papers. I had no idea what in the world I was writing. And I was so confused and was excited when I made a B in abstract algebra because it was the hardest class I ever took. And it was all proofs. So tough. But it makes these proofs seem so easy. So yay.
All this kind of stuff. And I texted him like when we first started doing proofs, and I was like, yo, I need help. And he's like, okay, let me get some stuff. My college books and I'll put stuff up. The stuff you're doing is so easy. If you want to have a proof that 0 equals 0.
I'm telling you, and it just gets crazy. And the proofs can get so hard because they're abstract. They'll be all abstract where there's no numbers, and you're just like, oh my goodness, what in the world am I even doing? I don't even understand. So yeah, it can get crazy, but we're not there. We're not crazy, so it's going to be fine. No, not here. No, not in high school. Not even in calculus. No. It's later. Yes, 1 step. Thank you, Tyler. I almost stopped. Number 9 should be, yes, triangle. JKN is congruent to triangle. And be careful. I always end up counting off for students forgetting their triangle symbols or putting angle symbols instead of triangle symbols. So be careful. LMN. They will. Definition of congruent triangles. Yes. And I promise you, the whole chapter 4 has a pattern. Okay? It will help. It will not be as tough.